So in today's lesson, we're going to talk about adding and subtracting rational expressions. In the previous lesson, we did multiplying and dividing. And I think multiplying and dividing rational expressions is a little bit easier than adding and subtracting. So normally in the progression of mathematics, you add, subtract, then multiply, then divide, but we flipped them for rational expressions for a good reason. So on problem 97 out of the CPM textbook, they want you to refer back to your homework problem that you did yesterday, problem number 92. And technically in a team, you would look to see if you guys all came up with the same answer for that problem, which was 1/3 plus 2/5. And then kind of have a conversation on to hopefully we all got the same answer, why we got this answer, why we got that answer. So if we proceed to A, Monica's sister wants to know why. She wants to ultimately know why is it that we have to find a common denominator when we're adding fractions. So what is a fraction anyways, and why does adding them have to be so complicated? Draw some pictures or diagrams to make up the situation to help her know why what 1/3 and what 2/5 mean. And then for B, we're going to kind of put these together a little bit. And then B, now use your idea from part A to show Monica why she needs a common denominator to add the two fractions. So when you guys are probably first introduced into fractions, they would draw out like the rectangles, and then you would make them evenly spaced and fill stuff in, which is exactly what we're going to do. So we're going to start off with this 1/3. So this 1/3 is you're going to take technically a whole 1, and our 1 is always going to be the same size. So I'm going to go with, I think these little, right? Probably should have done this ahead of time and kind of counted these out to where I could be an evenly true 1/3, but I'm going to, I think I'm pretty close, right? So when it comes to a fraction that has a 3 in the denominator, it is saying that you are taking this one whole and you're splitting it into 3 equal parts. The 1 is saying that you are actually going to fill in, or you have, or whatever, you have one of those thirds, right? And then, so we'll write that out. So this is our 1/3. And then if we look at our 2/5, since it's still a fraction, it's a fraction of a whole, right? So that 5th is saying that we're still taking that 1, which is the same size as what we had up above. I didn't do too bad, right? But now, instead of separating them into thirds, we're now going to separate them into fifths. So I'm going to go here, 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 and here. It actually worked out pretty nice, didn't it? And then out of my 5 equal pieces, I'm going to fill in 2. So I have 2 of the 5. And it could be any 2 of the 5, but just to keep it nice and easy, I'm going to sit there and fill these 2 in, right? So now they want us to add these 2 pieces together. So this is where the problem comes in, with it being where our denominators are not the same. Those pieces are not the same space, they're not the same area. So when I go to add this, it's like, well, I guess I could say, you know, I have a 1/3, and if I wanted to drop this down, like, and if I put that in here, right, that's another 1/3. So I know I have 2/3, but then how much is that little piece right there? We don't know how much that little piece is right there. I mean, granted, we could go through some crazy math to figure it out, but this is why we want to find common denominators. So when we go to find a common denominator, we're actually taking that piece of that whole and then we're splitting it into those even parts and then filling in what we have, and then we can easily add those up. So our common denominator on this one would be 15. So and if I did this correctly, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Hey, it worked out good, right? So then now, I kind of cheated a little bit. I made this one, oh, I slid it over, didn't I? We'll fix that. There we go. Now we're lined up nice and easy. So now if I sat there and if I looked at my 3/5 and I brought my 3/5 size down, right, because it's going to come right down this line, it's going to be 1, 2, 3, 4, all of those 5, right? And then I'm going to add it over, but then when it comes to looking at my 2/5, if I bring my 2/5 down, it's going to be how many? It's going to be 6 of them, right? It's going to be all 5 of those, plus there's just one more little piece. So it's going to be another 6. So 1, 2, 3, 4, 5, 6. So out of our 15 pieces, or 15 slices, we now have 11 of those 15 that are found or added together, right? So that's why when it comes to our fractions, it's very important that we find a common denominator. Granted, we didn't draw out this whole model. We probably just did 1/3 plus 2/5. We know that it has to have a common denominator of 15. Right? 3 times what's going to get me to 15? 3 times 5. So 1 times 5 is 5. Same process on the other one. 5 times what's going to get me 15? 3. 2 times 3 is 6. We add the tops and we have the same denominator, right? Same answer. On the left, it just kind of gives you a nice little picture representation or a model of why that's true. So now we're going to look at problem 98, which states, extend the procedures your class developed for numerical fractions to add these algebraic fractions. So now we have 2 algebraic or rational functions that we are adding together. So the same exact principle applies that we just used adding 1/3 plus 2/5. The same thing applies. So let's work through this problem together. So I'm going to rewrite it. So we started with 2x over x minus 1 plus 3 times x plus 5. Right? So no different than in our previous example, we have to find a common denominator. So if it helps, I always take these little guys, my denominators, and I throw them in parentheses because that is all one piece. That's all one number, just like what we were doing when we were multiplying and dividing those rational functions. That's a factor. So throw those parentheses around there, and sometimes it makes it a little bit easier. So when it comes to finding our common denominator, we have to have like the same factors when it comes to these being algebraic fractions. So in the denominator, we have that x minus 1 and that x plus 5. So when it comes to adding these and finding that common denominator, our common denominator has to have both of those. So our common denominator is going to be, I'm going to write down what our common denominator is going to be. Our common denominator is going to be x minus 1 times x plus 5. Okay? I'm going to, well, you know what, I'm going to throw that below there. Save me a little space. Alright, so to add these two together, I'm going to make my little fraction bar just a little bit wider. So I always write down what I originally had. So I originally had 2x and x minus 1, right? And I originally had 3 and x plus 5. But we know that our common denominator has to be this x minus 1, x plus 5. So when I look at this guy, what am I missing? I'm missing the x plus 5. So I'm going to add it in a different color just to start with. So that's going to be my x plus 5, right? And since I multiplied the bottom by x plus 5, in order to keep this equivalent, I have to multiply the top by the same exact thing. So I got to multiply the top by x plus 5. Okay? And then when I look at my second algebraic fraction, they gave me the x plus 5, but I'm missing something. What am I missing? I'm missing the x minus 1. So I need to multiply by my x minus 1. Since I multiplied the bottom by it, I need to multiply the top by it as well. And if you kind of wanted to check a little bit, like that, if you're looking for those common factors on the top and the bottom, like that x plus 5 would cancel out, and we're right back to where we started from. This x minus 1 would cancel out, and we're right back where we started from. And we don't want to go backwards to where we started, where we came from, but it's kind of a good little check to make sure that we're on the right track, right? So now that we have that common denominator, we can add these together. And we're going to do that piece by piece, but I'm going to make a fraction, and I'm going to put these all together now, because now I have my common denominator. My common denominator is x minus 1, x plus 5. And then on top, I have this little piece. So I have 2x times x plus 5. What am I doing? I'm adding these. So I have to add. And then I have, from my second fraction, 3 times x minus 1. All right? So now we just need to do some algebra to go ahead and reduce this and simplify this. So I'm going to take my 2x and I'm going to distribute or share with these guys. And then I'm going to take my 3 and I'm going to distribute or share to everybody, right, and do those guys. So nice little long fraction bar. We're going to leave the denominator the way that it is for now, right? So I'm going to do this first one. So 2x times x is going to give me 2x squared. 2x times 5 is going to give me a positive 10x. 3 times x, positive 3x. 3 times negative 1 is going to give me negative 3. So now I can look at my numerator, the piece on top, and then I can just go ahead and combine like terms. So to combine like terms, what do I have? How many x squareds do I have? I have 2x squareds. Plus, I'm going to draw my fraction bar, sorry. I'm going to look for my x's, not like my personal x's, the x's in the problem. So I have 10x plus 3x, which is 13x, and I do not have 13 x's. And then my constant term is that negative 3. And then I'm going to leave my denominator the way that it is, right? Just to get us started in this whole process. So on our next problem, we're actually going to look to where we're going to factor the top and then see if there's any like factors that we can cancel out, okay? So they gave us two problems for problem number 99. Now add the fraction below. After you add them, be sure to check to see if the numerator can be factored. And then if it can be factored, we're going to put it in the simplest form. Sound good? So I'm going to write this out. So for A, we have x over 3x plus 1 plus 2x squared minus 2 divided by x, oops, I kind of got a little sloppy there. Let me rewrite that. X minus 5, 3x plus 1. So first thing I'm going to do, I'm going to throw that denominator all in parentheses just so that it looks like nice one perfect little factor. And then I'm going to look through my denominators and I'm going to find all of those factors because I got to have everything in common. So I have a 3x plus 1 and a 3x plus 1. I don't have to write that out twice, right? If it's in one, it's good enough. Or if you have 1 in each one of the fractions, we're good enough. So my I'm just going to write it as my CD, my common denominator. What's my common denominator going to be? It's going to be that 3x plus 1. And then when I look at the second fraction, what do I still need? I still need that x minus 1. Or x minus 5, I apologize. Right? And I already covered the 3x plus 1. It's already listed there for my common denominator. Right? So I am going to write this, my original. So I have x over 3x plus 1. And I'm just going to make that a little bit longer. Plus my second one, which was 2x squared minus 2. And then I had x minus 5 times 3x plus 1. Okay. So when I look at my first fraction, I need to add what to my denominator? I need to add that x minus 5, right? I need to include, I guess I shouldn't say add, I need to include that, correct? Because they're being multiplied. So if I multiply the top or the bottom, I'm multiplying the top by the same thing. Now I'm going to look at my second fraction, and I'm going to compare that to that common denominator. Anything missing? Nope, there's nothing missing. So I already have a common denominator on that one. So I don't have to do anything with that one. Cha-ching, right? So now I'm going to write these as one fraction, all under that same common denominator of 3x plus 1, x minus 5. Right? So I'm going to add this part, but just to save a step, I am going to distribute at the same time. So I'm going to do x times x is x squared. X times negative 5 is going to give me negative 5x. What am I doing here? I'm adding. So plus this numerator, which would be 2x squared minus 2. So now we're going to combine like terms. So I'm going to look through how many x squareds do I have? Well, I got 1 here and I got 2 here. So I have 3x squared. How many x's do I have? I got negative 5 and no other ones. So negative 5x. And I have a negative 2 for my constant term. And that's over my 3x plus 1, x minus 5. So I'm going to take this guy up here now, just to kind of keep it all on one page for you. So now we have our common denominator. We've added the two fractions together. Now we want to see if we can simplify it farther. So we got to do some factoring. So I'm going to look at my numerator, right? Because my denominator, leaving it this way, it's already factored. So the only thing I have to worry about is my numerator, the piece up top. So I'm actually going to factor that one, and I'm going to use the little area model. Oops, I'm going to move that down just a hair. Right? I have 3x squared. I got to figure out some x's, and I have a negative 2. So 3 times negative 2 is going to give me a negative. So I know I have to multiply by a positive and a negative. And when I multiply that together, I get 6. So I have 6 factors of 6. So we get what? 1 times 6 and 2 times 3. And when I combine those terms, I have to get negative 5. And since one's positive and one's negative, really you're subtracting those to get 5. So to subtract and get 5, I'm going to have to look at this guy, right? And since it's a negative 5, it's going to be a negative 6, and it's going to be a positive 1. So now I need to pull out my common factors. So that top left box, to get x squared, I know I have an x and an x. In order to multiply to get 3, either I'm going to have my 3 here, or I can have my 3 here. So I got to make a decision. So if I put my 3 here, and I look through the rest of my box, 3 times what is going to get me to 1? 1/3, which is a fraction, and we don't want that. So we know that the 3 has got to go to the top, right? I'm going to go to the bottom left, and so now I have, and you can go in any order, it doesn't matter. 3x times what is going to get us negative 6x? That would be a negative 2. Right? Now I'd have x times what is going to get me to 1x? A 1, and technically a positive 1, right? And then I'm just going to double check. 1 times negative 2 gives me my negative 2. So I know I sat there and I went ahead and factored it correctly. So now I can write that as my factors. So now my numerator I can write as 3x plus 1 and x minus 2 over my denominator. Don't forget this guy. And my denominator was 3x plus 1, x minus 5. Now I'm looking for those common terms, or those common factors that are in the numerator and denominator that are going to divide out to be 1, or we call it canceling each other out. And so I have, oh, I don't want to erase. I have 3x plus 1 and 3x plus 1 that match up perfectly. And then I have x minus 2 and x minus 5. Those babies don't match up, so they're going to stay. So my answer is going to be x minus 2 divided by x minus 5. And remember, I cannot cancel these out. These boys do not cancel out, right? That operator is a subtraction in there. It's not multiplication. You're only canceling when, see, remember these guys are being multiplied. They're factors being multiplied. And I'm going to leave B for you guys to work on for a little bit of practice. And if you guys got any questions, check in with me. Give me a shout out.